This is example 6 of the Order of Operations lab. We have two sets A and B. We have set A is 1, 3, 4, 6, 7, 9. Those are the elements in that set. And in set B we have the elements 2, 3, 4, 5, and 6. And we have the questions. For example, in part A, find the intersection of B. So this is a phrase that's the intersection of A and B. Or you can say it's A and B. So you can say A and B. And what that means is elements that are in both sets A and in set B. So if we look at this, 1 is only in set A and not in set B, so it would not be an element of this set. 3 is in both A and B, so 3 would be in this set. 4 is also in both sets, so 4 is in the A intersect B set. 6 is actually in both sets, so 6 would also be in this set. 5 is not in both, 7 is not in both, 9 is not in both, so the set A intersect B, or A and B, consists of the elements 3, 4, and 6. You can also think of it as a Venn diagram. For example, if I had a circle containing everything in set A, and we had a circle that had everything in set B, A intersect B would be this bit right here. Everything that they both share. So they both share 3, 4, and 6. So 3, 4, and 6 would be in this area in the Venn diagram. So that's part A. In part B, we want to find A union B. Another way to say that is A or B. So what this means is anything in A or anything in B. And if we look back at the Venn diagram, it's basically the same thing as saying everything. Everything that is contained within all of these sets. So it's everything, like that. All right, so we have, so this set would consist of, since A has 1, it would have 1. Since, I'm just going to go in order of numbers, since B has 2, we're going to include 2. They both include 3, so I'm going to include 3. They both include 4, I'm going to include 4. It has 5, it has 6, it has 7, and it has 9. So any elements that are in A or elements that are in B. So basically everything. And we can exclude, so you wouldn't have to say 4 twice, even though it's in there. Okay, so that's parts A and B. So in part C, they want us to find all 2-element subsets of set A. So set A is 1, 3, 4, 6, 7, 9. So, and only care about set A. So 2-element subsets is essentially we're going to take 2 elements and it's just going to be a subset of A. So for example, so we're going to have a large subset containing all the 2-element subsets of A. And in there we're going to have little subsets of 2 elements. So the first 2 elements I see are 1 and 3. So there's a subset containing the elements 1 and 3. Then there's also 1 and 4. And then there's also 1 and 6. There's also 1 and 7. And there's also 1 and 9. In problems like these, it's important to find a pattern so that you don't miss some. And then moving on from the 1s, we've done everything with 1. I see 3 and 4. And then 3 and 6. 3 and 7. 3 and 9. And then now that we've done all the 1s and 3s, I'm going to move on to 4s. So we have 4 and 6. We have 4 and 7. 4 and 9. Now the 4s are done, we're going to move on to the 6s. We have 6 and 7. and we have 6 and 9. And then we also have, lastly, we have 7 and 9. And since sets are the same no matter what order you write the elements, for example, this set here, 1 and 3, is the same as the element set containing elements 3 and 1. These are all the 2 element subsets of A.